Okay, so now we're on the back here for the second video, and we're going to get into a couple more laws of logic. First of all, the idea of deductive reasoning. It's a system for reaching logical conclusions. So based on information, that allows us to say more information or to learn more things. One of the laws of logic is called the law of detachment. If P implies Q is a true conditional and P is true, then Q is also true. So if you know that P implies Q, if that is true, and then let's say the next statement is P again, then you know for a fact that must lead me to Q. All right, so example number 7. GUS students, GEMS United School students, are good at geometry. Okay, so I'll use capital G for GEMS students. GEMS United are good at geometry. Jennifer is a GEMS United School student. Well, if Jennifer is a GUS student, then that puts her right back to here. Okay, so if Jennifer is a GUS student, what does that mean? Well, that leads to she's good at geometry. So basically, we are just repeating the argument. You're allowed to do that. So we can say, therefore, Jennifer must be good. Jennifer is good at geometry. Okay, so again, I'm using the symbols to write it. By writing it out, it makes it easier for me to see. So if this is true, and then Jennifer is a GEMS United student, then, okay, we already know that leads to good at geometry. All right, let's try another one. Number 8. If a vehicle is a car, then it has 4 wheels. Okay, so let's assume this is true. A car has 4 wheels. A Porsche is a car. Well, if it's a car, it has 4 wheels. If a Porsche is a car, then it has 4 wheels. That is a valid conclusion. Therefore, a Porsche has 4 wheels. Okay, number 9. If the Yankees win the World Series, this is baseball, then I will cry. So if the Yankees win, I will cry. That's true. I hate the Yankees. The Yankees won the World Series. Well, that's just repeating this. So if the Yankees won the World Series, what happened? Unfortunately, I cried. Therefore, I cried. If the Yankees win the World Series, I'll cry. The Yankees won the World Series, okay, then I cried. Now, the last one, number 10, though, this is a little tricky. If the Yankees win the World Series, then I will cry. So we'll start it the same way. Yankees win, I cry. I am crying. Now that starts with C, and it's the same as this. Y implies C. Can I say that C implies Y? That would be a converse, but the converse is not always true. So if I'm crying, it could be because somebody said, I hate geometry. It could be because the Dallas Cowboys won in the NFL. There are a lot of reasons why I could be crying. So in this case, Yankees lead to crying. Crying does not have to lead back to Yankees. No conclusion. It's very subtle, the differences, and I know this can be very confusing, but after you've practiced it a few times, when you see a few of these, it'll make more sense. Okay, the last one here is called the law of syllogism. It's also called the chain rule because it looks like a chain. It's a chain of reasons. If P implies Q and Q implies R, then P implies R. So I'm going to write it a little differently. I'm going to write it out on a line. If P leads to Q and Q leads to R, then that means that the first thing eventually must lead to R. So you'll be able to say, therefore, P implies R. If P leads to Q and Q leads to R, then that means the first thing P has to lead you to the last thing R. Okay, so we've got a few more examples. Number 11, if Maria gets an A in geometry, she'll celebrate. Okay, if she gets an A, she will celebrate. So A leads to C. If she celebrates, so now we're going to continue here, then her friends will join her. So if she continues, if she celebrates, celebration leads to friends joining. Okay? So look at how this works. Now, this is not a converse. Just because we start with C again, because it leads us to a new thing. A leads to C, C leads to F, therefore, A leads to F. It's a chain of reasoning. So the way we write this here, we will say, therefore, the first thing, that's if Maria gets an A in geometry, I'm just going to say if she gets an A, what's the final outcome? What's the final conclusion? It will lead to her friends joining her. Then her friends will join her. I apologize for running out of space here. Okay? She gets an A in geometry, she'll celebrate. If she celebrates, her friends will join her. So that means if the first thing, then the last thing. Let's try another one. If you go hiking, you'll get some exercise. So if you hike, you'll get exercise. So let's write H leads to E. Hiking leads to exercise. If you get some exercise, you will be tired. So if you get exercise, that leads to being tired. So what's the big picture here? Well, if you go hiking, eventually you will be tired. Therefore, if you go hiking, then you will be tired. If you go hiking, you will be tired. This is the law of syllogism, or easier ways, the chain rule. It's like a chain of reasons. H leads to E, and E leads to T. Therefore, H leads to T. If a quadrilateral has 4 congruent sides, then it's a rhombus. Okay, so here's a geometry one. If we have 4 congruent sides, then it's a rhombus. That's true. If it's a rhombus, then its diagonals are perpendicular. Oh, a lot of vocabulary. Okay, if it's a rhombus, then the diagonals are, that's our symbol for perpendicular. Again, look at the chain. So the big picture is, if you have 4 congruent sides, then we can say that the diagonals must be perpendicular. That is true. Okay, so therefore, if, now I'm going to copy this, if a quadrilateral, I'll say quad, has 4 congruent sides, so if the first thing, then the last thing must be true. So then its diagonals are perpendicular. It's okay if this is a little frustrating. It does take some practice. If you win the lottery, then you will have lots of money. Okay, so if you win the lotto, we'll say lotto leads to lots of money. If you play professional baseball, then you will have lots of money. Now here's the problem. Lotto leads to money, but we don't start with money again. We start with something totally different. We start with baseball. Baseball leads to money. Now, both of these may be true, but that doesn't mean that lotto and baseball are related to each other. That's not a chain of reasoning. Therefore, we can't make that conclusion. I can't say anything about those two. We don't know that they're related. So this is not a chain rule. It doesn't work. So you say no conclusion. All right, 15. All humans are mortal. Socrates is human. Now, this one's a little bit out of order. So can we make this a chain? So let's say Socrates is human. All humans are mortal. So here we go. If you're a human, you're mortal. Socrates, if you're Socrates, you're human. Now, that chain doesn't work like that, but what if we put this first? What if we say, okay, Socrates is a human. All humans are mortal. Look at the chain right there. Now we can do this. Therefore, the first, Socrates, must be must lead us to the last. Okay, so therefore we can say Socrates is mortal. All right, we got two more here. Now, number 16, what conclusion can be drawn from the following? You have 4 statements, all with a bunch of letters, okay? Each letter is a statement. Some of them have negation. Can we make a chain from this? That's the question. Now, you'll notice that C appears twice, F appears twice, G only appears once, and P only appears once. So what that means in the chain, you're going to have some things repeat themselves. In the middle, those are going to repeat themselves, but the ends will only show up one time. So what we want to do is start with one of the ends. So I'm going to start with G implies B. Okay, I'm going to put it over here. G implies B. Okay, we use that. Check that off. Now, for a chain, we have to start with B again if we're going to make a chain. Well, here's a statement with B, but this is in the wrong order. C implies not B. Now, I can't start with C here. I have to start with B. But don't forget that the contrapositive is equivalent. So the negation of this is B. That would imply not C. So I can use this. Okay, B implies not C. Notice we have not C implies not F. This does not start with not F, but let's use the contrapositive. Not F implies not P. There's the chain. Okay, so what that means is that G leads all the way to not P. Therefore, G implies not P. That is a true statement. That's a valid conclusion we can make. The other part of this, you may be asking, but what if we had started with P instead? Would that have been wrong? The answer is no. What would have happened is we would have gotten the contrapositive of this. So if I switch these and negate, I would say P implies not G. That would have also been possible. Okay, just to show you, and I know we're kind of running out of time here, if I had started, I'll do it over here. P implies F. Here, I'll put it in green. So P implies F. Then we need to start with F. So that would be this one. I would take the contrapositive. F implies C. Okay, that's good. C implies not B. That's good. Now, not B, I have to do the contrapositive. Implies not G. Implies not G. Now I have my chain. P implies not G. And look at that. We have our answer. I am going to leave 17 for you as a challenge problem to see if you could figure this out. A lot of words. What I would recommend is use letters to represent this and see if you can make the conclusion. And to finish the notes, let me tell you one more joke. What do cows most like to read? And the answer is catalogs.